When you created your .gain project in InDesign, you generated a PDF that was sent to the image setter. And that is where this printing plate came from. You should be aware of two properties on the printing plate. We have the image area here, which is the silver halide. That is very receptive to ink, and it does not like water. It is hydrophobic. Now the black area is the non-image area, and that accepts water. That is hydrophilic. So the concept that oil and water do not mix is one of the tenets of offset lithographic printing. If you think of the ink as the oil, silver halide, and the water as the clear area here, the two will not mix. Okay, so now we're going to punch the two holes in the printing plate. We're going to bend it, and we're going to mount it on the machine for printing. The press has a semi-automatic plate mounting system. So all I need to do is push one button several times through the cycle to install the plate. And I'm going to do that right now. We will hear a series of beeps, and that will prompt me to do some action. There's our first beep. And I'm going to slide the plate into the clamps here. And push the button again. Okay, that beep tells me the plate has been installed, but I want to physically verify that with my own eyes to make sure it has been successful. And there I see the clamp and the printing plate, so the plate has been successfully mounted. Now we're ready to print. And we start that by putting ink into the machine. And here you see the ink reservoir with ink in it right here. And this section here has the dampening solution. I'm just going to drop this lever right here. Both systems very separate. The first thing we will do is apply a very thin coating of the dampening solution onto the plate to wet it. Then we'll apply the ink and we'll start the production process. Now you should be aware that the fountain solution, it's mostly water. And we actually distill the water to take any impurities out of it. And we add a buffering agent, and that keeps the integrity of the plate intact. It helps the ink dry, and it's very important that we keep our dampening solution at the correct pH, the correct conductivity, and the correct temperature. If any of those factors are not correct, we will have problems with the printing process itself. Now, I have taken manual control of the press so that you can see the blanket down here with the image printed on it. You can see it is wrong reading or reversed. And what I'm going to do now is very slowly inch the machine, and you will see the paper coming up here as it has been printed. Don't be confused. This roller you're looking at here is an ink roller. It does not touch the blanket. It will only contact the roller which is below it right here. And that roller below it is a form roller, and that contacts the printing plate. This does not touch the blanket at all. So I'm just going to rotate the cylinder around, and you will see the paper coming up. And this is the impression cylinder right here. That's where the squeeze is taking place. A little bit of pressure there between the blanket and the cylinder to squeeze the ink onto the paper. Here's the paper coming up, held on grippers. You can see University of Houston. It's right reading. Wrong reading here, right reading on the paper. I'm going to stop this right now, and I'm going to show you a different view of the grippers. I'm just going to close this one, open this one. Okay, so this is the impression cylinder right here. And I'm going to control it manually here. and you're going to see a piece of paper supported by the grippers on the cylinder. And there's the paper right there, and supported by the grippers. It's supported all the way through the machine from entry to delivery. Now you should be aware that one of the main pressure points at this point that will cause dot gain is actually in the blanket. If the blanket is sitting too high or too low on the cylinder, your dot gain will be affected. If it's sitting too high, it means there's going to be a lot of pressure between the blanket and this cylinder. So those little dots that are in there, they're going to be squeezed to a much bigger area than they should be. If there's not enough packing in there, your dots may not even print. So I'm going to rotate this on through here. And this blanket here is unit 2. We're not printing anything, but if we were, this is the point where the impression would be made. The pressure is between the blanket and the cylinder. There's a squeeze. That is controllable, and it must be controlled to control our dot gain. And here we have the grippers for the second piece of paper. Okay, so now you've seen the impression cylinder. I'm going to cover it up again, and we're going to look again at the front of the unit here, where we can see the printing plate, the printing blanket, but you cannot see the back cylinder. So you have seen one of the pressure points, the blanket here. You've seen that where it touches the impression cylinder. Overpacking will cause dot gain. The other pressure point actually is on the printing plate. As you see here, the printing plate does touch the blanket. Again, it's the same principle. If we have too much packing on the printing plate, it will increase the size of the dot as it goes onto the blanket. To ensure proper offset lithographic printing work, to make sure that we maximize the quality, we need to make sure we run everything to specs. That'll include our dampening solution, proper temperature sitting between 50 and 60 degrees, proper pH sitting around 5.8 to 6, proper packing on our blanket, proper packing on our plate. And we must also be aware that our rollers that you see here are carefully set. They are set to specific pressures from the roller itself to the plate, from the roller to the plate. There is one dampening form roller and 3 ink form rollers on each unit. They must all be set precisely to the plate. And after that, we have a variety of rollers in the ink reservoir itself that must be set to each other. Okay, the press is pretty straightforward to operate. All I'm going to do is start the machine, drop the dampening form rollers, let the dampening solution get a very thin layer onto the plate. Then I'm going to drop the ink rollers, and then I'm going to drop the production button. Once I hit the production button, the paper will automatically pick up, feed through the machine, make the impression, and deliver. So first I start it, and now I'm going to apply the form rollers for the dampening system. What it's doing right now, you should be able to see the plate get a little bit shiny, a little bit wet. That is the thin layer of dampening solution covering the plate. Okay, now I'm going to drop the ink form rollers, and if you observe the silver halide in here, you can actually see it. It's going to turn the color of the ink, and the ink we're using is black. So you should see that change to black here pretty soon. There you see it turning. It looks pretty black to me. Now I'm going to start our production, and that will feed the paper through the machine. As the paper feeds through, the ink is transferring from the printing plate to the blanket, the offset, then it's transferring from the blanket to the paper. It's going in between the blanket and the impression cylinder, the paper, and it's being squeezed onto the paper itself. Okay, now I'm going to stop the impressions, and we're going to look at the output on the delivery section of the machine. The phenomenon of dot gain is inherent in the printing process. In other words, it's a fact of life. We just have to live with it. But what we do is try to compensate for it. Now, you have seen some of the work we did on the printing press to eliminate the dot gain as much as possible. That was the setting of the rollers, the proper control of the dampening solution. And now we have our product printed. This is our project right here. So we're pretty much ready to go with the densitometer and our loop here to examine how big the dots got on the paper. Now, when you sent the file, you created the dot size to a particular percentage. And what we are going to measure is how much larger those dots got during the printing process. It immediately starts to dry. The pressure at that point will make the dot a little bit bigger, but once the dot hits the paper itself, it will start to spread, thereby giving the sense of a larger dot. It actually is a larger dot. Uncoated paper is notorious for high dot gain because the ink will be absorbed through the fibers of the paper right into the paper itself. Uncoated stock, the ink will sit on the coating of the paper and pretty much polymerize or dry right on the surface of the paper. So there's very, very little ink spread with coated paper. Hence, with coated paper, your dot gain values are much lower. Okay, so at this point, we're going to actually measure the values of the swatches that you created, and we're going to use the densitometer for that. This is the densitometer right here. Its main function is to measure density, but it will calculate dot gain values for us as well. Before we start to actually make the measurements of the dot gain, we want to see where the dots actually start occurring on the paper and where they stop occurring on the paper. Now, when I say stop, I mean where the dots are going to start to bump into each other. And you really won't see too much space between the dot, and we want to look for that pattern. When a regular dot pattern stops, that's what we're looking for, both in the upper and the lower numbers. Traditionally, the dots will start to print around the 4 to 5% area, and they will start to disappear or merge into each other in the upper 90s and around the 94, 95 area. So I'm going to take the loop here, first thing I'm going to do, and I'm going to look at your dot patterns here. We had 1, 2, 3, 4, 5, and 6%. And I'm going to look for a very regular pattern, and that will be the start number. So 1% here, there's nothing. 2%, 3%, nothing. 4%, I can see dots start to come, but not too many. And at 5%, I see a reasonably regular pattern of dots. So we're going to circle the 5% there. That's where the dots start. I'm going to do the same thing at the upper numbers right here. And 93, it's actually quite low here. 87, it looks not too bad. But 86 is showing a regular dot pattern. So we will circle 86. So that is our range where the dots start and stop. Now we take the densitometer and we're going to measure all of the dots that are left, all the swatches, and see how big the area has become. And to do that, we're going to use the densitometer here. So the first thing we need to do is calibrate the densitometer itself. So I'm going to bring the cursor down to calibration function itself, enter it, and we're going to calibrate to this little white swatch right here. And we just hold the densitometer down. It's completed, and that is our densitometer calibrated. The density is the main feature on the densitometer, obviously hence its name, but it will also measure dot gain for us. And all we do is pull up dot gain here. We must follow a sequence of measurement. The first thing we want to measure is the paper itself. Then we want to measure the solid that was printed on the paper. This solid is an identical density all the way across the solid itself here. That was achieved by adjusting the flow of ink onto the paper on the printing press. And if this density is not the same all the way across, we will not do this experiment. These densities must be the same in your 100% swatch. So the first thing I'm going to do then is measure the tint per our sequence here. Measure the paper. Let's measure that. Then I'm going to measure the solid itself, the 100% swatch. And now we're ready to go to work with all these little swatches here. We have lots and lots to do, so it's going to take a little bit of time. I'm going to measure every single swatch from the 5% range where the dots started to occur up until the 86% swatch where the dots started to disappear. And with those numbers, you will be able to generate your dot gain curve. So I'm going to go start the measurements. And measuring the 6% swatch here, it's showing 8%. So rather than that little swatch occupying 6%, it now occupies 8% of that paper. Our dot gain value is 2%. So we're just going to continue this sequence all the way up, and I'm going to write down the dot areas above the swatch. There we have the 7%, and it's on 10, so you have a 3% dot gain. Now I did mention that the dot gain values tend to increase in the mid-range, so I'm going to pop up right here to the 50% one just to see what our dot gain value is at that point. And the 50, it's 75. So we have a 25% dot gain on the 50% swatch, which is quite high. The standard dot gain value for uncoated paper using offset lithographic printing techniques is approximately 20%. So we have, actually we're within range here, we're doing quite well. The 50% swatch measures 75, so we have a 25% dot gain. It's a little higher than it should be, but it's running at 25%. So I'm just going to keep on measuring here and write the numbers down for you. And you can see towards the upper numbers here, I'm measuring the 84 swatch, and it's showing an area coverage of 98. So this is getting very, very close to a solid at this point. And when we get to the 86, it should be pretty much solid. That's where the dots will be overlapping. And there you see that at 99%. So that's as high as we're going to measure there. I still have a few of the lower numbers to do here. In addition to giving you the dot gain values that you need, we have also fingerprinted the Ryobi 3202 press. And the numbers that you have been given here can be used over and over again. This press will generate dot gain values consistent with the ones we just measured. That will be a phenomenon of this press. So the numbers that we generated here, they will be used in future files for the grayscale adjustment of your images.